Here we are in section 3.3 exercises, part A, numbers 1 through 12. It says to simplify the following. So we'll be using our rules of exponents. So if you have those handy to refer to, it will help to answer any of these questions. The first one, 3m squared all to the fifth power. So that's going to give us 3 to the fifth, and then m squared to the fifth power. So 3 to the fifth power we can do in our head if we know it, or we can do 3 to the fifth power will give us 243. Then m squared to the fifth, the rule of simplifying when you have an exponent to exponent is that they multiply. So this will be m to the 10th. Okay, let's check that answer. Number 2. X to the 7th times x to the 11th. This is the multiplication rule, and the combining of the exponents, since they have exactly a like basis, is that you add the exponents. So that is going to be x to the 18th power. This has 7 x's, that has 11 x's, all multiplied together. So the number of x's adds when we are multiplying those two things together. Let's check our answer. X to the 18th. Good. Number 3, f to the 12th divided by f to the 5th. The division rule means that we take those two exponents and subtract them. 12 minus 5 will give us f to the 7th. Let's check that answer. Yes, indeed, f to the 7th. Okay, number 4, t to the 8th times t to the 5th. This is the multiplication rule, which takes those two numbers and adds them. So we'll have a t to the 13th. Let's check our answer. T to the 13th is correct. Number 5, 3 to the negative 4. Negative exponents. That negative rule is that we take 3 to the 4th and it is now on the denominator. It flips it. It puts it on the bottom. It divides. So 1 over 3 to the 4th is, we could do 3 times 3 times 3 times 3, or 3 to the 4th power is 81. So it's 1 over 81. Let's check our answer. 1 over 81 is correct. Number 6, 3x to the 7th times 4x. Well, in multiplication, the 3 times the x to the 7th is as simplified as it can be. 3 times 4, we know that is 12. Now we have an x to the 7th times an x. There is a 1 up here, x to the 1st. So we are doing the multiplication rule. 7 plus 1 is x to the 8th. Let's check our answer. 12x to the 8th. Correct. Number 7, 3z to the 5th over 12z cubed. Well, if we look at this as two different problems, 3 over 12 is 1/4. That's right, that makes sense. Now, z to the 5th over z cubed, this is the division rule like we did in number 3, where exponents subtract when we divide like bases. So 5 minus 3 would be a z to the 2nd power. So 1 times z to the 2nd, or z squared, is just z squared, and then 4 in the denominator, z squared over 4. And correct when we check our answer. Number 8, 17 to the 0 power. Anything to the 0 power always turns out to be the exact same number, and it is 1. 17 to the 0 is 1. That's our 0 rule. Let's check it. Indeed, 1 is the answer. Number 9, this is g to the 8th to the negative 2nd power. This is the power to the power rule. So we are multiplying exponents. So we get g to the negative 16. Well, negative exponents aren't simplified. We're going to do what we did up here in number 5 and put that on the bottom. 1 over g to the 16th power. Correct your answer? Yes, 1 over g to the 16th. We should note that this is not incorrect, but it's not considered simplified while it has negative exponents in it. Number 10. This looks like a bigger problem. Let's try this. 14 over 21 we can view as an individual problem by itself. 14 over 21, we can take out a 7 and a 7, and we get 2 over 3. Now here, for the d's, we have d to the third, d cubed, over d to the seventh. So d cubed over d seventh, we subtract because we're dividing. 3 minus 7 would be d to the negative 4. Well, what do we do with negative exponents? Yeah, that guy moves down to the bottom, so we have 2 over 3d to the fourth. Now you should note that we could have, if you can see that, there's a little shortcut, that when you're dividing, if you subtract from the bigger number to the smaller number, the bigger one will win. That's why we have a d to the fourth on the bottom. You can follow the rule top minus the bottom and it gives you a number on the top, but if it's negative it'll have to go down to the bottom. So you could do a shortcut and subtract 7 minus 3, knowing that you'll end up at the bottom at the end. And there we have it, 2 over 3d to the fourth. Number 11, 2m squared into the fifth, g to the eighth, all to the seventh power. So each one of these, this seventh power, has to be here, and here, and here, and here. Now these exponents raised to exponents, they multiply, just like we did up here in number 1 and number 9. So we get 2 to the seventh, m to the 2 times 7, that's 14. N to the 5 times 7, that is 35. And g to the 8 times 7, which is 56. Now notice this, they're all to the seventh power, but the shortcut with the exponent that's already there is multiplication. That doesn't mean this beginning 2 is timesing 7. It is indeed to the seventh power. So let's find out what that number is. 2 to the seventh power, 2 x to the y seventh equals 128. So we have 128 m to the 14th, n to the 35th, and g to the 56th power. Wow, that was pretty big. Let's check and see if we got it. 128 m to the 14th, n to the 35th, g to the 56th. Alrighty, number 12. 5x squared times 4x to the 7th. Well, multiplication, 5 times 4, we know that is 20. Now, x squared times x to the 7th, this is our multiplication rule. We add the exponents. 2 plus 7 give us 9 x's all multiplied together. Let's check our answer. 20x to the 9th. Good.